Imagine uncovering ancient dinosaur eggs that don't just tell us what roamed the Earth millions of years ago, but also rewrite our understanding of the world's prehistoric climate. That's exactly what just happened, and why so many scientists are buzzing with excitement, and maybe a little debate. But here's where things get really interesting. For the first time ever, researchers have directly dated dinosaur eggs using a groundbreaking method, potentially reshaping everything we thought we knew about the Cretaceous period's shifting environment. The Cretaceous period wasn't exactly a walk in the park. Picture relentless volcanic eruptions, oceans running dangerously low on oxygen, and devastating waves of extinction. Even so, Cretaceous fossils continue to provide a treasure trove of clues about how Earth's climate once shifted in ways nearly impossible to imagine today. Recently, a team led by Dr. B. Zhao at the Hubei Institute of Geosciences set their sights on a truly remarkable find: thousands of dinosaur eggs discovered at Qinglongshan, the first national reserve in China dedicated to these types of fossils. Spread over 3 sites, more than 3,000 fossilized eggs sit in layers of rock ranging from coarse breccias to fine sandstones, much of them almost perfectly preserved where they were originally laid. But what truly sets this discovery apart is the dating technique the team used. Traditional methods often rely on analyzing volcanic rocks or ash layers near the eggs, which can be imprecise because those formations may not match the exact time the eggs were laid. Here's the part most people miss. The research team tried something new: carbonate uranium-lead (UPB) dating directly on the eggshells themselves. Using a micro-laser, scientists vaporized minerals from the eggshell and measured the ratios of uranium turning into lead, much like reading the ticking hands of a radioactive clock. The result? The eggs were laid about 85 million years ago, give or take 1.7 million years, right in the heart of the Late Cretaceous. This is a major leap forward because, until now, the exact ages of dinosaur eggs at Qinglongshan were uncertain. Dr. Zhao calls this a revolution in establishing truly accurate timetables for dinosaur egg fossils around the globe. Imagine the possibilities. We may now be able to trace when different species lived, migrated, and potentially how they responded to climate upheavals in far greater detail than ever before. Let's talk controversy. There's fascinating debate among scientists as to just how much declining global temperatures, starting millions of years before these eggs were laid, impacted dinosaur diversity. Some even believe the shift from a warm to a cooler world set the stage for fewer species and fewer eggs across sites like Qinglongshan. And here's something to chew on. The eggs mostly belong to Placoolithus tumiaolingensis, featuring highly porous eggshells associated with the Dendroolithidae family. These unique pores might represent an evolutionary experiment or adaptation to cooler, changing climates. But could it be that these adaptations didn't go far enough? Dr. Zhao posits that this particular dinosaur, T. tumiaolingensis, may have hit an evolutionary dead end, unable to keep pace with the increasingly chilly environment. Although the study only analyzed a small set of eggshell samples, all confirming similar ages and aligning with the surrounding sediment, plans are already underway to sample eggs from different layers and locations. Doing so could help paint a much more detailed snapshot of how dinosaur populations changed over time and perhaps even track their migrations across ancient landscapes. There's also an open call for further research on eggs in nearby basins to investigate broader evolutionary responses to climate change. And this is where we invite your thoughts. Do you think advances in dating techniques can clarify the full story of dinosaur extinctions, or do some mysteries of prehistory remain forever out of reach? Could the unique structures in certain dinosaur eggs really reflect rapid evolution in response to global cooling? Or do you see another explanation? Are we on the verge of connecting the dots, or just scratching the surface of an ancient puzzle? Jump into the debate. Is this new dating method a revolution, or do you see pitfalls in relying so heavily on new technology? Share your perspectives, questions, and even disagreements in the comments below. After all, Science thrives on lively discussions and fresh viewpoints.